This graph is in this nice, neat, completed square form. We notice there's a 1 out in front, and that basically is a positive value, so we know that this graph opens up, and it's going to have what I call standard curvature. We'll talk about that in a second. Now, the vertex can be found by looking at these other two values, and the vertex will be at -3, -2. Notice I changed the sign on the -3 coming out of the parentheses because h is what we're looking for, but we have x minus h there in the formula. So that is our vertex. So let's go straight down to our graph and plot -3, -2. That will be 3 units to the left and 2 units down from the origin. Now we said that this is going to open up with a standard curvature. If we go back to our standard parabola going through the origin, notice how we can go over 1 and up 1 and over 2 and up 4. We're going to do the same thing down here with this. We're going to go over 1, up 1, and by symmetry have a point to the left, over 2 and up 4 to have another 2 points. Now we have 5 key points through which our parabola is going to run. Now, this has a minimum value, and that minimum value is -2. Notice how that is the same as the y-coordinate of the vertex. We also see that the axis of symmetry can be drawn in, and I will abbreviate that as AOS, axis of symmetry, and that is the equation x equals -2. Notice how the -3. Notice how the -3 and -2 match the values that we've written down for the vertex. Now let's get some practice with another problem. We can easily identify the vertex to be at -1, +2. Remember, we changed the sign of that 1 when it comes out into the vertex form. This value of -1/2 out in front tells us first off that this parabola opens downward because it's negative, and we can think of it as having a kind of slope with a rise of -1/2 and a run of 1. So let's use those key features here. Our vertex will be at -1, 2, and it's going down 1/2 over 1, which gives us 2 more key points right there. Now, personally, that's all I need. They didn't ask for additional points, so that would be our graph. Notice that we have a maximum value, which is 2, which is the same as the y-coordinate of the vertex, and that the axis of symmetry is the equation x equals -1. For this next problem, the vertex is going to be located at +1, -4. We have a +3 for this value out in front, telling us it's going to open upward. So let's plot 1, -4, our vertex, down here in the 4th quadrant, and our kind of slope of 3 says we can rise 3 and run 1 in each direction and get 2 more points that'll be on our graph. If we want additional points, we'd have to use an XY chart. And notice we have an axis of symmetry, which is the equation x equals 1, and that there is a minimum value here, and that minimum is at -4, matching up with our vertex, which is at +1, -4. Now, going back to the previous problem, they want us to find the x-intercepts. Well, you should know that whenever you want an x-intercept, you let y be 0, and anytime you want a y-intercept, you let x be 0. So we're going to apply that property here. Let's find the x-intercepts, and that basically says let y equal 0. Well, 0 now is equal to 3 times x minus 1 squared minus 4, and we have a quadratic equation. I'm going to begin by adding 4 to each side to have 4 equals 3 times x minus 1 squared, and then I'm going to divide each side by 3 to have 4/3 is equal to x minus 1 squared. Now we can square root each side of the equation. That will give us plus or minus the square root of 4/3 is equal to x minus 1. And we can't have that denominator with a radical in the denominator, so we need to multiply by root 3 over 3. And that will give us plus or minus the square root of 12, which is 2 root 3 over 3 is equal to x minus 1. And adding 1 to each side, we will have x is equal to 1 plus or minus 2 root 3 over 3. Now, when we're asked to find the x-intercepts, we can't leave it in this form. X-intercepts are points, so we'd rather have these written as 1 plus or minus 2 root 3 over 3, comma, 0. And technically, I probably should separate that into two separate points, but you can understand what I'm doing by combining them here. On number 7, this is in a ready-to-graph form. Our vertex is going to be at -2, +1, and we've got this 2/3 out in front that tells us it's going to open upward, and if we think of it as a kind of slope, we can think of that as telling us to rise 2/3 and run 1 to get an additional point. So let's plot these. -2, 1 will be right there. When I rise 2/3 and run 1, I get to some kind of weird points there. Technically, that first one is at -1, 5/3, and this one on the left there is at -3, 5/3, if it helps to have them identified. If I want an additional point, notice how the next point out will be on the y-axis, so I can substitute in x equals 0 to the original equation. If I substitute 0 in, 0 plus 2 is 2, which squares to 4. Multiply 4 by 2/3 to get 8/3. Add 1 to get 11/3. So at 0, 11/3, I will have my y-intercept. Well, 11/3 is 3 2/3, so I can plot that point right there. And by symmetry, I'll have another point over at the left at -4, 11/3. And so that's a way that I can generate a couple more points that will be on the curve rather easily.